Inequalities in one triangle. So if we add two numbers together, we get a sum. Okay. Now I'm going to make the argument that the two numbers I want to add together are both positive. If I add two numbers together that are both positive, what can you tell me about the sum in comparison to either of the two numbers that we added together? It's going to be bigger. Okay. You've all heard the phrase that the sum is greater than the parts, right? You never been on a team, football team, and they talk about the team being greater than the individuals? Yeah. The sum, so the sum would be the team, right? And the parts would be the individuals. So the team is greater than the individuals, okay? So that's the same idea. If I take two numbers, take 2 plus 3, you get 5, right? Is 5 bigger than 2? Yeah. Is 5 bigger than 3? Yeah. Fabulous, okay? That's the comparison property of inequality, okay? Now that's when A is greater than B, okay? We're saying that A is greater than B when we take B plus C and C is not negative. We're saying C is greater than 0. That will always be the case. So I think for our purposes right now, we're just going to worry about if the two numbers we add together, B and C, are both positive, then your sum is going to be greater than either of those two things. Okay. That gets this. I'm not going to spend a whole lot of time on this. I'll introduce this to you, but we don't really need this very often. Don't take your time right now. I think this is pretty self-explanatory, though. We know that 3 and 2. These are the remote interior angles compared to this exterior angle, right? We have a theorem that says, what do you do with these two things to get this red one out here? You add them together, right? Add the blue ones, and they give you the red one. So what is that red one? What is angle 1 in comparison to angle 2? It's automatically got to be what? It's got to be bigger. Angle 1 has got to be what compared to angle 3? It's got to be bigger. Does that kind of make sense? And that is directly saying that if you're taking two numbers, which are these angle measurements, and those have to be bigger than 0, right? They have to be positive. And I'm adding them together to get this number here. So this number out here has got to be bigger than either of these two individual positive numbers. So that's a direct corollary to this property. Okay. Is that doable? Yeah. Okay. So those are two pretty bland, pretty basic concepts for triangle inequalities. Another one that we've already seen, and this is why we'll kind of zoom through this lesson today, is this one. If I know what the largest angle in a triangle is, where do you find the largest side? It's opposite, right? And if I know the smallest angle, where do I find the smallest side? Opposite it. Okay. And I can flip rules, right? If I know what the largest side is, opposite it should be the largest angle, correct? Okay. And so forth with the small. That's what this is saying. Okay. Again, I'm not sure that that's something you need to put in writing right now. Hopefully maybe that's something you already have. All right, so those theorems that we just talked, I've got them called different theorems here, but basically what they're saying here is if I look at this red angle here, okay, I know that red angle is 44.87, and if I look at this purple angle, 51.24, just by looking at those, so I don't even care what this angle up here is, but if I'm just comparing that angle to that angle, okay, then the red one is smaller, right? And does that allow me to say then opposite the red angle should be a smaller length than what is opposite the purple, right? Yeah. Okay, now if angle A is bigger than both those, then the side opposite angle A will be bigger than 15.6 and it'll be bigger than 14.12, right? If it's smaller than both, then it'll be smaller than 15.6 and smaller than 14.12. If it's in the middle of 44.87 degrees and 51.24 degrees, then it'll be in the middle of 15.6 and 14.12. That's all that those last theorems were saying, okay? And we can also do the same thing by not starting at the angles, but starting at the side lengths and say, okay, opposite 15.6, that angle's got to be bigger than what's opposite 14.12. Is that okay? Yes, Jagger.
So, like, if you would have to put down, like, if side A was, like, bigger than 15.6, would you also have to put 14.12 since 15 is bigger than 14.2? Like,
I'm not following what you're
you
saying.
have to write both sides down since if it's already bigger than 15, that automatically means it's bigger than 14.12.
Yeah.
Oh, I see what you're saying. So if I didn't know this side here. So let's say we look at that angle. So that is bigger. So then if we look at this distance, you're saying, would I need to write that segment BC because that's bigger? Since I'm saying BC is bigger than AB, do I need to write that BC is bigger than AC? Because you know that AB is already, by the transitive property, bigger than AC. It just depends on what the question's being, how it's asked, how it's phrased. They might say, put them in order, least to greatest. That's, you would be right that I only need to say that BC is bigger than AB. And then because AB is already bigger than AC, then it's essentially the transitive property of inequalities that would kind of save you there. Yeah, it's a good question. Okay, here's a question. If I were to give you randomly, every person different, 3 varying lengths of sticks, okay? Yardsticks, but chopped up in different lengths, or pieces of string or wire or something like that. Will every one of you be able to make a triangle by sticking or by placing the endpoints of your segments end to end?
No. No.
Some say yes, some say no. So if I gave you, let's do it, let's see. I thought I had some tape here. If I take this piece of tape, that piece of tape, and that piece of tape, can I put them endpoint to endpoint? Like this. So where they're all going to touch.
No.
Because this third side here, my left hand is, needs to come down here and touch this, right?
Yeah.
Is there any way, so I could take this apart, maybe do, will they touch then? No. Okay. So will these 3 segments make a triangle?
No. No.
No. Okay. Will,
Yeah.
Imagine it still though.
will these 3, it's kind of messy now, easy. Save something. We'll use that. But that's the idea, okay? So I'm taking 3 varying lengths, okay? So you saw one situation where no, you can't, okay? And that situation where no, you can't would be something like this, where I take maybe those distances there. So this is piece of tape, piece of tape, piece of tape, right? I'm just gonna let one side be static. I'm not gonna move the red one, okay? But I can move this one here. That's still 2 no matter where I move it, right? Wherever I rotate it to. So I'm trying to think maybe they don't touch, right? So 2, 7, and 12, those lengths, they don't work, okay? They do not touch. What could I do? I can make that 7 go a little bit bigger, right?
You could increase the blue value.
Okay, so let's move that one to 3. Okay, now do they touch?
No. You need like 2.
Okay, so now they're gonna touch, right?
No.
They're not touching there. So what I've got here, let me take, I've made these yellow ones really large so I could
Wait, they're
grab them,
that's 12 exactly.
okay? But let's look at, are those touching?
No.
No. So now if I do that, are they touching? No, because if I zoom in, there's still a gap here, right? So I'm going to zoom back out and move them a little bit further down.
Nope.
Now, it might look like they're touching there, but let's zoom in. You can see that there's still a gap between them, right? Okay, so let's move them down here. And it might look like they're overlapping, but let's zoom in on them again.
They don't touch because they're equal.
Okay, so you see that this one here, they're not touching yet, right?
They're equal to
So you're seeing that they're equal to
the hypotenuse.
that, well, don't say hypotenuse. It's not a right triangle, right?
The base.
So their lengths together are the same as that red one, right? So only until, let me see if I can snap that one. There we go. There we go. All right, so now if I zoom in on these yellow dots, no matter how far I zoom in, you only see the one yellow dot, right? Okay, so that tells me that they are now touching, okay, but did they create a triangle?
No.
No, okay, but you were seeing that those two distances did what in comparison to that one?
They're equal.
They're equal. That sum is equal to that one. Okay. Now let's see if the same thing happens. So let's go. Let's change this to let me go to like 20. So we go 10 and 5. Is that the same situation?
Yeah.
Okay. If I go 11 and 5, same situation, right? Okay, so getting the idea that it doesn't matter what these lengths are as long as they are, the smaller two are adding to give me the biggest one, we're going to get the situation where we get kind of like a collapsed triangle. We don't really get a triangle. Okay, so what has to happen is let's make that one a little bit bigger. It doesn't matter. I make the blue one or the green one bigger, or I could have made the red one less. But now that I do that, they touch, right? Now they share, and we get a triangle, okay? But what are you seeing in comparison to these two smaller numbers? How do they have to relate to that one? Has to be bigger. Okay, now, the red one was the one that I was allowing to be kind of the static one that we did the comparison to. So let's actually let the red one be one that we mesh with, so the red and the green. Can I make the red and the green the way they are? Can I make them touch? Well, the red and the green, or the red and the green and the blue come together to allow me to make a triangle. What do I have to do? Change one of these. What do you want me to change the red one to so that it makes a blue one?
8.
Or connects with the blue one. Make the red one go to 8?
Oh.
So we're getting there, right? Okay. So now those were the two smaller ones, right? So what are you seeing that we have to do with the two smaller segments of a triangle? What do they have to be so that we can actually so we take these three segments and actually make a triangle? Okay, their sum has to be greater than the third side. Okay. Now, when we say greater, this is we're talking about inequalities. We're talking about infinite number of possibilities. So 12 is the third side, right? So if the sum of my smaller two are 12.000000000, as many times as you guys say 0, and then put a 1 on the end of it, that is greater than 12, right?
Yes.
So those three distances then would make a triangle. Now there would be a very little yellow area, okay, but it would still make a triangle. Okay, but this is called the triangle inequality theorem. Okay, in which if I want to make a triangle, okay, or we can phrase it that all triangles, the smallest two sides sum is greater than the third side. Okay, the smaller two sides is greater than the third side. Does anybody know why? What's going on in the background here? Right, let's go back to this 12, the red. Let's bring this down here. What am I tracing out if I were to highlight that yellow?
A circle.
Okay, and what am I tracing out there?
A circle.
Okay, so what's going on here is that we've actually got a circle there and a circle there. And those circles, what are those two circles doing right now? They're overlapping, they're intersecting, right? The place that those circles are intersecting is the location that these segments need to go to so that we get a triangle. So there's one situation. Now, is this triangle down here? Is that the same triangle?
Yeah.
Yeah. Okay. Now, just some stuff that we've talked about in the past. And this all ties into things that we've dealt with. I don't usually talk about this, but we've got a little bit of time. So that triangle up there would be the same thing, right?
That's a kite.
Okay, that's a kite. There's a perpendicular bisector of that segment right there. Does that make sense? Okay, so any point on this perpendicular bisector would be equidistant from that point and that point, right? So it'd actually be, any point on the red one would be equidistant from that point and that point. But once we start changing, let me get rid of that line and that line and that one. Do we make a triangle there?
No.
Because the circles don't intersect, right? Okay. So a lot of people always ask, what are we learning about in this course? And most of the time we learn about triangles, right? Because triangles are then the building blocks for other things. You even see relationships inside circles, right? There's a trigonometry study of triangles is based off of circles. Okay, that's the most convenient way that we can understand and learn triangle and angle relationships is through the use of circles. So there are, even though you might not think of it right off the bat, but there are a lot of relationships that exist with triangles because of circles and vice versa. You guys remember what we said those two triangles right there, or those two circles were right there? If they only touch at one spot? Start with a T. There is a word for it. TA in tangent. Okay, so those circles would be tangent, and that's the situation where the sum of the smallest two sides is equal to the third side, right? And that's why we have no triangle. Okay, we don't have a third vertex. Basically, it puts all our points collinearly, or aligns them collinearly. All right, so that's the triangle inequality theorem. Says, I don't like the way that I have it written here because it basically shows you, it says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So this is just basically saying take any two sides of a triangle, add them together. If you have a triangle, it should be bigger than the third side. Okay, and that was true. Okay, but the ultimate test that does all of this a little bit quicker, okay, is if we take this is the way I would write it: the sum of smallest two sides is greater than the third side. Okay? If that's true, or you have a triangle with the parts that are given, or we're going to argue that that is true for all triangles. Okay? So they'll ask you questions like this. They'll say, do the following segments create a triangle? What are the smallest two sides? 8 and 4. Is their sum greater than the third side?
Yes.
Yep. Number 2. What's the smallest two sides?
4 and 3.
4 and 3. Is that greater than the third side?
Yes.
Yep. Anybody know what kind of triangle that is?
Isn't it?
That is a right triangle. Okay. Because it satisfies, if I go 3 and 4, and this has to be 5, what's 3 squared? 9. What's 4 squared? 16. Add those together, you get 25, right? Which is 5 squared. Is that a squared plus b squared equals c squared?
Yes.
And that is a theorem that works only for right triangles. What about this one? 3, 3, 7.
It's not gonna work.
Nope. Okay, so 6 is less than 7, right? What about 9, 11, and 12, 20?
No.
No, that's when they're equal, right? So you got to be greater. The sum's got to be greater. Cannot be less than, cannot be equal. They're going to ask you questions like this. If two sides of a triangle are, let's say 5 and 8. What are the possible lengths for the third side? Say again? Okay, so one possible length would be 14. Okay. Now here's the thing. It's not necessarily 14, because if I add those two numbers together, 5 and 8 gives me, when I add them together, I get 13, right?
Yeah.
Okay. So would 13.1 be greater than 5 plus 8?
Yeah.
Okay. So what we want to do here is on this question, the assumption is early on is that these two are the shortest. Those are the shortest sides of your triangle. That's the assumption that we make. So then the third side has to be bigger than their sum, right? So the third side has to be 13, okay? But just to the right of 13. So our, let's write this way. Third side let's see here. We'll write this in inequality a little bit better here in a moment. So assuming that those two are the shortest, then we add those together, and 13 is a critical value for us. Let's put it that way. Okay. Now we know nothing about this triangle that I gave you of sides of 5 and 8. Obviously, 8 is bigger than 5, so there's no way that 5 could be the biggest side of the triangle. Does that make sense? But 8 could be the biggest side of the triangle. Does that make sense to everybody? Because I don't know that third side. So if 8 is the biggest, that number there, that could be the middle one. Does that make sense? So if that's the biggest one and that's the middle one, anybody know how I could find the smallest one? Subtract them. Okay? So if I subtract those, I get 3, right? Okay? So what has to happen there is that my range of values are going to be between my third side, are going to be between 3 and 13. Now let's try this. Now it's got to be, I put these inequality signs in there because I'm not going to be 3 or 13 because that would make them equal, right? That would make the sums equal. And that's the problem. So like 3.01 or 3.001, or I'm just going to go 3.1. Let's try a couple third sides here. I'm just going to let x equal my third side. So if I go 3.1 and I have a side of 5 and I have a side of 8, is that sum of 8.1, is that greater than 8? That makes sense? So does 3.1 fit in this range? So 3.1 works. Okay. If I try like 5, is that sum greater than the third side? Yeah. Okay. So we're good there. So let's say our third side is 10. So this would have been 5 and 8 were the shortest, okay, like we started off with. And now 10 would be the longest side, right? Does 5 plus 8, does that end up being bigger than 10? That makes sense? What if I said 14 though? If x is 14, 1 is 5, and 1 is 8. Those are the shortest. If I add those together, okay, which gives me 13, is that sum bigger than 14? No. So I would not have, going back to kind of this image here, I would not have ultimately circles intersecting, therefore the creation of a triangle. Does this kind of make sense? So I want to give you a reason why, or somewhat of a visual of this route, but basically to find the upper boundary, add the two values given. To find the lower boundary, subtract the two values given. But the reason or logic behind that is because we don't know at the onset whether we are being provided the two shortest sides or we provided the longest side and the middle side. No, because the way we read this is that the third side, we're going to read a couple different ways. The third side is greater than 3. Okay, because if the third side is greater than 3, then it's going to match up that like 4 and 5 would be added together to give you something bigger than 8, right? Or 5 and 5 added together to give you something. And the third side has to be less than 13. Because if it's greater than 13, then these are two will be the smallest, and they do not add up to be greater than. Yeah, so the way that we read this is that 3 is less than the third side, which then the third side is less than 13. So what that does is it allows us, basically saying, if you guys go back to, now this is going to be kind of hard. I don't have the programming right now to demonstrate this using just segments, but I can show you using some shading here real quick. All right, so you guys remember talking about, like, if I were to graph like x is less than 13. You guys remember, now visualize this as, instead of being a shaded region, there's like a line going that way. Does that make sense? Let's see if I can actually do, let's say, I can't, it'll be too much programming right now. So my values have to, so if we're just shading the x-axis here, those are all the values that are less than 13, okay? If I graph x is greater than 3, okay, so that would be everything now that is like that pinkish purple color, right? And then the overlap of things that were less than 3, or greater than 3 or less than 13 would be these values in here, right? And I think did I type in 13 or did I type in 14? So everything that is less than 13, let's move this over a little bit. Come on. Everything less than 13 is that stuff there, right? Okay. Everything that is greater than 3 is that stuff there. everything that is greater than 3 and less than 13 would be this region here that is overlap, right? So if I type in, so I can unhighlight these, type in 3 is less than x is less than 13, it'll automatically just shade that region. And you guys did this a little bit last year, or you should have. If this is my variable x, and I have my number line, and 0 is there, let's say 13 is there, and 3 is there, that this right here, if I read it from the variable side, so the third side here is the variable side, I would say x is greater than 3, right? X is greater than 3, so that would mean x is represented by all of those values there that are to the right of 3. If I read it based on that, I would say x is less than 13. So it'd be all of those. But the way this is called a between statement. So the way we really read it is 3 is less than x and x is less than 13. So it's an and that we call an and statement. So an and statement is where they overlap, and they're going to overlap between 3 and 13. That kind of makes sense? You'll never have, and clarify or correct me if I'm wrong, but I think you're trying to say that you would have something like this. You'll never be able to write something like that. These two symbols, done correctly, will always point to the left. Okay, you might see occasionally, sometimes people will write them both pointing to the right. If they both point to the right, then the numbers are not chronological. So meaning that the number all on the left should be smaller than the number that's all the way on the right. Does that make sense? Okay. If both arrows are pointing to the right, the 13 would show up first, and then the 3 would be afterwards, and that's just backwards. But what that would say right there is that x is greater than 3. That's what that says right there, correct? So think about numbers that are bigger than 3. And this says x is bigger than 13. Okay, so numbers that are bigger than 3 are one condition, and numbers bigger than 13 are another condition. Wouldn't that better be written as just saying, well, they're x bigger than 13? Those are the numbers that are bigger than 3 and bigger than 13. So that's why you'll never see them pointing in opposite directions. Okay? If we point them like this says x is less than 3 and x is less than 13. Okay, well that would be all values that are less than 3. So that would just be easier to write that way. So the reason we'll always write them pointing in the same direction, pointing to the left. All right, but to find this lower value, subtract the two numbers they give you. Find this upper value, add them. Does that make sense? Did that answer your question?
Yeah.
Okay, all right. Do you guys have any questions over this? Anything else is this pretty easy to grasp? Okay.
Can you open the test again?
Yes.